Hello, my name is Tyler Farley, and I am a senior at Lone Star High School. I am a part of the Independent Study and Mentorship Program. This year I am studying chemical engineering, and my mentor is Amanda Grazita, who is a chemical engineer at Frito Lay. What you're about to see is my final product. In this video I've interviewed 4 different chemical engineers and asked them various questions regarding the chemical engineering field. I believe chemical engineering to be a very diverse and amazing occupation that one is able to change the world and solve many different problems. I really hope that you enjoy this video and that you learn a lot. Thank you so much.
The possibilities are really broad with chemical engineering, which is one of the reasons it really appealed to me. Across a lot of different industries, there's a lot of flexibility with career paths. So with a chemical engineering degree, you can go anywhere from petroleum engineer to pharmaceuticals to, like something I do, the consumer products industry. So working for companies like Frito Lay or developing new diapers or anything you have around your house.
Many chemical engineers go into many different industries. For example, I work in consumer product goods or product development. There's a lot of people that do R&D or non-R&D roles for oil companies, chemical companies, and pharmaceuticals as well. So it's a general broad degree. We also call it process engineering. Just because it's called chemical engineering doesn't mean you work with chemicals.
I think any engineering role, you really have to have kind of a technical curiosity. So if you find yourself to be somebody that asks, like, why does that work, or why doesn't it work, or how could it work better, I think that's kind of a quality that you should always have, just kind of in engineering in general.
I hired in 2001, so I think the skills required at that time were, and why they kind of sought out engineering and chemical engineering degrees is one, problem solving skills.
Yeah.
So it's a major that does require quite a lot of abilities in math and science and just kind of working through how to get things done. With the knowledge that you have. There's not always a clear answer to anything in life, and I think they just look for people that have gone through that process. And
so I think chemical engineering is different from other engineering programs in, I guess, maybe 2 ways. One is the focus on chemistry and, I guess, the building blocks of stuff, right? So obviously there is, you take organic chemistry and physical chemistry and you understand from a component standpoint, kind of how things work and how that applies to different processes. So there's that piece. The second piece, though, that I think is more important, it's the difference between chemical engineering and other engineerings, is the process mechanics behind things. So from sizing pumps, fluid and mass flow, transferring things, that's a big piece of chemical engineering that applies to a bunch of different industries. From electrical engineering standpoint, you're working on circuits and you're working on, from computers and equation standpoint, or mechanical engineering, you're working from a building's bridges or spans, or understanding weights and thrusts and different things there. But from a chemical engineering standpoint, you've got a lot more breadth in terms of process, and so I think from an opportunity standpoint, there's a lot of different things you can go do with it. So I think, there have been a couple. I would say the one thing that's great about chemical engineering is that from a fundamental standpoint, like the fluid, heat, mass transfer, the chemistry, the science, it's all pretty well established. So that hasn't changed over the course of 10, 15 years. A lot of industries, like from a technology standpoint, there's been like a radical shift of, hey, you learned something 15 years ago and now it's outdated. I would say from a chemical engineering standpoint, you learned it and you know it, and that's been the same, like from a fundamental principle standpoint. I think what has changed is the way it gets applied. So it's gone a lot of, I would say, from problem solving to problem solving, but from a technology lens, or kind of looking in a different way. So trying to figure out different ways to do things and utilizing technology in new ways. I would say today there's a lot more sensors for things, a lot more programs that can do stuff for you. So it's helping you solve problems in a different way, but the fundamental problems, I think, are still the same as when I started in chemical engineering.
As more industries emerge, technology industries and analytics industries, I think that chemical engineering, or in any engineering, kind of that problem-solving skill set, I think it just makes it an incredibly diverse degree that's going to fit any future.
So it's really everything we touch. Our food, our products that we make here, snacks. Chemical engineers design the processes to make those snacks with the highest quality and the most efficiency possible. You think about any pharmaceutical you take, so any kind of pill or vitamin, there are chemical engineers that are designing the processes to make sure that those things are as safe as possible and exactly what they're intended to be. Anytime you put gas in your car, it's a chemical engineer or petroleum engineer that's designing how do you get natural resources out of the ground, how do you process them most efficiently, and how do you get them to the people that need them. So it's really just everything we do.
Yeah.
When you think about it, chemical engineering is kind of behind the scenes, I'd say.
Chemical engineering is probably important to almost any product that you'll find in the market. In essence, chemical engineering is process engineering, which is how do I start from one thing and go through a transformation process or in a factory or in a plant or even in your house and contributing to something as a finished product. So for example, on Doritos, that's starting with real corn kernels, real corn cobs that we harvest from the fields, and converting that through a series of processes to get to a finished product in tortilla chips. With pharmaceuticals, that's starting with the core ingredients that go into the drugs that they're manufacturing and ending up in a pill format or a liquid format. So chemical engineers are needed to touch every one of those processes. We're experts in how do I go from one step to the next, to the next, to the next, and making sure we're making the right calculations and conserving mass, conserving energy, and getting the right desirable functional output of each one of those. So almost any product that you buy will have had chemical engineers in some way, shape, or form touching or transforming that product. At Frito Lay, a chemist might focus more on the components or the compounds that are in our products. For example, they might look at a specific oil type and look at the types of lipids that make up that oil component. So looking at the double bond structure, are they saturated, monosaturated, doing that kind of analysis and understanding how there may be an impact on our shelf life or the product quality. With that, they may be looking at the components we use to make our packaging and what kind of a barrier those form. Are those compostable? Are they biodegradable? Things like that. They're looking at the individual flavor components down to that kind of more microscopic level and determine those functional pieces of the product. And that applies to all of our products, not just one particular platform or product. Chemical engineers are more looking at the larger scale. Whereas now I'm talking about a process or a unit operation where it's how do I optimize this fryer? How do I optimize this oven or this process of taking our raw materials and moving them to a different part of our process? So I'd say chemical engineers are more on the larger scale and chemists are more looking at different pieces or the smaller components within a product. I'm sure that's not always the case for everywhere across the chemical engineering industry. I'm sure that chemical engineers and chemists are working together on these things, but typically when I think more chemists, I'm looking more at the microscopic level. How do we diagnose things? How do we look at changes at the more microscopic level?
If you said at least 15 years ago, if you asked what does a chemical engineer do, they probably refine oil. They design distillation columns and make plastic. So I think just knowing the breadth of where chemical engineers end up after their degree is probably the biggest misconception.
I think the biggest misconception, at least that I had going into chemical engineering, was that, you're going to be doing a lot of chemistry and you're going to go work for an oil and gas company. Especially down here in Texas, that's the thing. You go work for an oil and gas company and that's it. So you're going to make petroleum fuels and plastics, and that's going to be your whole career. And I think what I've learned being in the industry, and at least when I was at school, was that from a chemical engineering standpoint, there is a massive range of things that you can go do. We here at Frito Lay employ a ton of chemical engineers who make potato chips and Cheetos and Fritos. I know chemical engineers who make bowling balls. I know chemical engineers who actually make coffins. You can make and go into a ton of different industries with a chemical engineering background versus you think, it's chemistry and it's, worrying about this carbon molecule and this. No, it's process and the different ways we make things. And so I think that's kind of a mind shift that a lot of, from a misconception standpoint, you go into it having.
My favorite part of my job now is, getting to design delicious snack products that people love. I mean, that's one of the choices I made in college, and considering all the different industries I could apply my degree was, which one did I want to go into? And making stuff at work that you can then tell your friends and family about, and they can go to the grocery store and pick it up themselves and buy it. It's so much fun.
I think the favorite part of my job is the fact that I get to work on so many different things and solve different problems. I think from an engineering standpoint, you get a great fundamental in terms of how things work and the process by which things get transformed. And so I think that's unique in that if you go into finance, hey, you're always working on numbers and math and spreadsheets and dollars. And if you go into marketing, marketing has a bunch of different aspects to it, but you're kind of doing that same thing. From an engineering standpoint, you could be working on anything. And so I think that from being able to solve those problems, do engineering problems, and then translate that to something that somebody's using or eating or buying is really unique in that you can apply it to a bunch of different ways.
There's two things that I really enjoy about the job, among many things, probably the two biggest ones. First of all is overcoming a significant challenge that maybe at the start of the project we didn't know how to accomplish or how to achieve. For example, I worked on Doritos Locos Tacos for Taco Bell, and one of the challenges there is no one had ever seasoned taco shells at that kind of scale to the quality we were looking for on the Doritos brand. So our team, in partnership with many engineers and other people in our Frito Lay business, developed a system to cool them and season them in a way that was just as efficient as our normal chip processes to deliver a consistent product to Taco Bell that got purchased over 1 billion times by consumers in the field. So overcoming that challenge of it not existing and developing it from scratch, and looking at going to Home Depot and finding all kinds of different ways to test theories and hypotheses. When we got to the end, it was really rewarding to know that we'd overcome that challenge. The other thing I find really rewarding about the job is seeing the product on the shelf. So it's a really cool experience to one, go on YouTube, for example, and see somebody taste testing your product and testing Sweetos or Cheetos Bag of Bones for the first time, and seeing how excited or how engaged they get when they see it. It's like, wow, that looks like a real Easter egg, or these taste amazing. Seeing commercials for Doritos Locos Tacos on TV was a really cool experience, and it gives you that very good sense of achievement for what you've worked on, and you can see that you can connect with people in your everyday life. When you tell someone you work on a brand like Cheetos or Doritos, you immediately see their eyes light up. It's like, oh, I love Cheetos or I love Doritos. You can see that impact you make on them from a fun and engagement standpoint, instead of maybe working on, call it, no, I don't like that, because you're trying to encourage people to go too. You could probably just cut it there.
Okay.
I'm a recruiter too for our group, so
okay.
We recruit against oil and gas and chemical. So
gotcha.
It's not as exciting to say, hey, I work on styrofoam.
Right.
Or I made this package. Yeah. Nobody cares.
Yeah.
When you say you work on Cheetos, like, whoa, that's so cool.
Right. Yeah. Definitely having that label and that accomplishment is really cool.
Mm-hmm.
Awesome. Well, that's a lot of really good stuff. Thank you so much.
Okay.